This is the second lesson on solving linear equations. This is so important that it's really worth spreading out the lesson and giving ourselves time to ground these skills. And again, even if you're confident in solving linear equations, I want you to be more than confident in just the process. I really want you to understand the why of the process. So there are a couple of unusual cases that we can see when we are solving linear equations. And these are things that don't come up all the time, but they do come up some of the time. And I want you to see them so that when they come up, you're not totally thrown by them, although we do want to approach them with caution. The first one, we'll work this problem out together, and this will give us a good review of the skill. If you've had me before for this or another class, you know that I do try to roll in review as much as possible into my lessons. So what we're going to do here, looking at the unusual cases, is review what we did last class with those steps. So here's my linear equation. Step number 1, clear of fractions. Well, there are no fractions here, so great. Step number 1 is done. Step number 2, simplify each side separately. By that, we mean distribute and combine like terms. So if I look at the left side, I see there is no distribution. If I look at the right side, also no distribution. So that brings us to the combining of like terms. On the left-hand side, I have a constant, I have an x term, and I have another constant. I can combine those two constants together. Remember that this is a -7, so you are doing a subtraction here. Just to reinforce stuff from another lesson, though, what I'm going to do here is use the commutative property. And just show you how that works. Remember that commutativity means you can switch the order of things. So if I think of this as a plus -7, what I can do is say, whoops, don't do that, is I can do 3x plus -7 is the same as -7 plus 3x. And that puts my two like terms next to each other, so I can clearly see that it's 11 plus -7 or 11 minus 7. If that kind of threw you off a little bit, then don't try to do it, okay? I didn't want to confuse anybody with that. I just wanted you to see the commutativity property at work. What we're going to do is 11 minus 7, which gives us 4, and then bring down the 3x. Over here on the right, I have an x term, a constant, and another x term, so I can combine the two x terms together. Again, remember that is a -3x. 6x minus 3x, if I have like 6 ice cream cones minus 3 ice cream cones, I am left with 3 ice cream cones. Put a little noun in there. And then bring down the plus 5. Anything you're not working with is just going to come down. Work from top to bottom. If somebody says, where did you get a 4? We got a 4 from doing 11 minus 7. I should be able to ask you questions about your work, and you should be able to explain what you did. Even if what you did was wrong, you should still be able to explain to me what you did. Next step is to get the variable on one side. Well, over here on the left, I have a positive 3x. If I would like that to cancel out, I can get there by subtracting 3x. Whatever I do to the left, I have to do to the right in order to keep the equation balanced. And here's where weird stuff starts to happen. I'm going to bring down the 4. 3x minus 3x is 0, which causes that to drop out. And what happens over here on the right is exactly the same thing. 3x minus 3x is 0. And of course, 4 plus 0 is 4, and 0 plus 5 is 5. And I get this statement of 4 equals 5, which should not feel right to you. First of all, because the variable's gone, which is weird, and because 4 does not equal 5 and has never equaled 5, and if you'd like to argue that it does, I have $4 and I will trade you my $4 for your $5 if they're actually the same, which they're not. When this happens, this is called a contradiction. That's the vocab word for it, is a contradiction. It means that we have a false statement. That is another word that you might see described to that. You can also see it as this. It means there is no solution to this equation. Remember, the solution to the equation is the value of x that's going to make this equation true, that I could plug in the value for x and I would get, 5 equals 5 or whatever. What this means is that there is no such number. There is no number x that exists that you could plug in to this equation and actually get it to work. Okay, so that's our first unusual case, is that thing called a contradiction. Next one, let's look at 6x plus 5 minus 2x equals 4 plus 4x plus 1. Step number 1, clear of fractions. Good news is there are no fractions. Step number 2, simplify each side separately. So we're going to distribute, but I don't have any distribution, so I'm good there. Step number 3, our next step in the simplifying is to combine like terms. Over here on the left, I have two x terms. I have a 6x minus 2x. That's 4x. Bring down the plus 5. Bring down your equal sign. Equal sign is the most important thing in an equation, so it should never disappear. Over here on the right, I have two constants, so I can combine those. 4 plus 1 is 5, and then I have the 4x. Okay, next step, get all your variables on one side. So once again, I have this positive 4x. I can get that gone from the left-hand side if I subtract 4x, and make sure you do the same thing to the other side. We always want to make sure that we're showing that. 4x minus 4x is 0. Again, that's why it cancels out. And we are left with 5. Bring down the 5 on the right. 4x minus 4x is 0. And this time I get 5 equals 5, which feels better than 4 equals 5, because at least it's true, but also really weird because the variable is gone from the equation. The word for this is called an identity. So you might see the word identity. We might say it is a true statement. And what it means is that every real number in the universe, as long as it's a real number, if you put it into this equation, it's going to end up working. It works. Now, when we get to our unit on systems of equations, there are some geometric things that come into play here. With this situation over here, it means that you have parallel lines, so the lines don't intersect, which is why you don't get a solution. And in this one, it means that you actually have the same line. So you have like one line and then the other line is right on top of it, and they intersect everywhere, which is why all the numbers work. Now, that being said, these are rare, but they do happen. If you're doing your homework and every single problem is coming out with the variables gone, you're doing something wrong. This should not happen in every problem. It really is kind of rare. So the first thing I would do is, if you're doing a problem and you're getting 4 equals 5 or 5 equals 5, the very first thing I would do is go back and make sure you copied the problem correctly and go through and check your work and make sure you did not make a mistake. It should be a red flag that maybe something went wrong. But if you check your work, everything looks fine, then you're dealing with one of these two special cases. And it's okay to leave it like that and move on. Again, if every single problem you're doing is coming out like that though, then there is a problem and you want to come to a tutoring session so that I can look at your work and we can iron that out. The last topic in this lesson on linear equations has to do with something called a literal equation. If you do like a little word study here. The word literal, if you think of literature, or if somebody's literate, it has to do with reading. More specifically, it has to do with letters. And so a literal equation has multiple variables. So we're dealing with, in literal equations, having something more than just an x. It's often our formulas, and you are familiar with formulas from geometry. We've got area formulas and volume formulas, and in your science classes, you end up with lots of formulas. If you have taken or are taking physics, you're going to deal with lots and lots of formulas that govern, say, force and mass. That's one of Newton's laws, or weight is equal to, that was the one I just had. But there's like tons of formulas. I was thinking of work. Work equals force times distance. That's what I was thinking. There's all kinds of formulas that are out there. That's your most common kind of literal equation. Now, when you're dealing with a literal equation, you're going to see the directions solve for. And you have to know what that means. If somebody asks you to solve for x, or solve for y, or solve for m, or g, or t, or s, or whatever the variable is, you need to know what the directions are asking you to do. So to solve for something means to get by itself. You can be the best math student in the world, but if you don't understand the directions, you won't be able to do the problem. So if you were to see the directions, solve for G, okay, solve for G, the way you interpret that is get G by itself. So you're looking at your formula and you want to get the G all by itself. So on the next slide, I'm going to put up a literal equation. This is actually a physics formula for, it can be free fall motion. If you drop something, it'll tell you how far it's fallen. So let's take a look at that. The formula is this. S actually is used for distance. I know most of you probably use a D. When you get into higher math, you don't, because it gets confused with something else. Okay, so we have S equals 1/2 GT squared. And the directions here are get the G by itself. So after you have your moment of panic about what are you supposed to do with this, then you're going to start reasoning through it. So let's highlight the G here. Let's think our way through the problem. I want to get the G by itself. So I've got some other stuff over here with the G. So here's my end goal. I want to get equal G all by itself. So I need to think, what do I have over there that I don't want there? And how do I get rid of it? So over here with the G, I have a 1/2. I would like that 1/2 to be gone. What is the 1/2 doing to the G? Well, it is multiplying the G. I also have over here a T squared. I'd like to get that T squared gone. What is the T squared doing to the G? Well, remember that that is multiplication. Okay, so now we've thought through that we have multiplication. And so the question you want to ask yourself is, how do I undo multiplication? It goes back to that lesson we did last time. You undo what you did. So if you have a multiplication, you can undo that multiplication with division. So if I'm multiplying the G by 1/2, I can undo that by dividing by 1/2. Okay, that makes sense. Now, this is actually algebraically sound. If you do this on a test or on the homework, I can't take off anything for it. It's pretty sound. But you're probably looking at it and saying, that looks like a fraction inside a fraction, and you would be right. It is a fraction inside a fraction, and it's awful. And we try to avoid it. We don't like to deal with fractions inside of fractions, even if it's correct. So what we're going to do is take a moment and think about whether or not there's another way we could do this. If you recall from a few lessons ago, I said there was no such thing as division. Division simply says to multiply by the reciprocal. Okay, all that vocab coming back. Division means to multiply by the reciprocal. So if I have G and I divide it by 1/2, that is what we're doing here. We're dividing by 1/2. We're ignoring the T squared for the moment. We'll come back to it, don't worry. That is the same as multiplying by the reciprocal. So that would be the same as G times, well, what's the reciprocal of 1/2? You flip it over, 2. Now, if I have the choice between dividing dividing by 1/2 and multiplying by 2, I would much rather multiply by 2. That's a much more straightforward problem. So over here, I'm going to get rid of this divide by 1/2 stuff because I don't actually want to do that problem that way. And I'm going to rewrite that as multiplying by 2. It's just nicer to write it that way. On the left, I have 2s, and then multiplying this. This is not distribution, okay? The reason it's not distribution is because you don't see any pluses or minuses. Distribution is when you multiply and inside the parentheses you're going to have a plus or a minus somewhere. This is just straight multiplication. This is 2 times 1/2 times g times t squared. So 2 times 1/2, come over here, I'm doing like my scratch work over here. 2 times 1/2, well, remember that when you're multiplying fractions, you just multiply straight across. So 2 times 2 is 2, 1 times 2 is 2, 2 over 2 is 1. So this becomes 1, and I don't need to write the 1, g t squared. And I'm pausing just so that you have a chance to write it down and think about it. Next step in getting the g by itself, we need to go back to this piece of information. I still got this t squared there. I don't want that t squared there. That's a bummer. But the t squared is multiplying the g, and I know that I can undo multiplication by dividing. If I'm multiplying by t squared, then I will divide by t squared. And t squared, I'm going to home in right here, where you have t squared over t squared. Well, anything divided by itself is 1. So this would be g times 1, or just g, and over here I have 2s over t squared. And what I have successfully done is I have solved that for g, or gotten the g by itself. Literal equations are actually easier to do than regular linear equations. I don't think I've ever convinced my students that they're easier to do, but they are, because they don't typically involve a lot of arithmetic. It's just doing the algebra with the variables. So I'm going to give you another example. This is going to depart from the notes. So if you're looking at the scanned copy of the notes, now we're getting into some extra stuff. But here's the most common situation where you might see, what do I want to do here? We'll make this in a 12. Okay, this is like kind of a silly problem, but the most common situation where you will need to solve a literal equation is an equation where you will see an x and a y, and you will probably want to get the y by itself. The reason you probably want to get the y by itself is because of this. If you guys remember y equals mx plus b, we haven't done it yet this year, but we will. And this is solved for y, meaning, remember, solve for means get by itself. So the y is by itself. So the most common application of this in an algebra class is trying to get the y by itself. So let's go through the reasoning process on this. We want to get the y by itself. I'm going to go highlight it, maybe not. There we go. And we're going to think about what's being done to the y, because that's going to dictate what we're going to do to get the y by itself. Well, the y is being multiplied by a -4. And then there is a 2x. Now, this is where it gets a little bit tricky to see, but I do want to point out to you that is a positive 2x. If it were a negative 2x, you would see a negative in front. So you could switch the order here. You could do -4y and then put the 2x over here. Again, that's your commutativity, which is why those properties are so important, because they frame how we think about it. I'll go ahead and write that over here so you can see it. 2x minus 4y. Remember that that's really plus a -4y. And then commutativity allows you to switch the order. So what you really have there is -4y plus 2x. And the reason I'm doing that is so you can see what really is happening to the y there. The y is being multiplied by -4, and then you're adding a 2x to it. So coming over here, if I want to get the y by itself, I have to get rid of this 2x. This is a positive 2x. So the best way for me to get rid of it is to subtract 2x from both sides. Now over here on the left, it's pretty straightforward. 2x minus 2x is 0, and then you bring down the negative 4y. Remember that that negative is attached to the 4y, so that's going to come down. Now here it gets a little bit messy. Up until this point, when we've subtracted, we've tried to line up our like terms. So you line up constants with constants and x's with x's or w's with w's or whatever. But if you look at this, these are not like terms. This is a 12 without an x minus a 2x, something with an x. Those are unlike terms. We can't actually subtract them, so we have to leave them written as is. 12 minus 2x. Now, if you want to, and a lot of times people do, they will switch that order. And again, that's your commutativity, but you have to be careful about the negative. The 12 is positive. The 12 has to stay positive. The 2x is negative and it has to stay negative. So if you opt to switch the order, you do have to make sure you bring that operator along with it. So now we've got the 2x out of the way. We still have the negative 4, but remember the negative 4 is multiplying the y, and we undo multiplication with division. Now here's another spot that makes for a pretty common mistake. If you divide the entire left-hand side by negative 4, you have to divide the entire right-hand side by negative 4. If you divide everything on the left by negative 4, but you only divide a piece of the right, then it's no longer balanced. We have to divide everything. Now, this is technically okay. If you're trying to go for that y equals mx plus b form, though, what's a little bit easier to do is when you say I'm going to divide everything, is to write it out separately. Write out your division separately. Either way is technically correct. Some of them are easier on the graphing calculator. It really depends on what you want to do with the problem in your next step, or if this is the end of the problem, then it'll influence the decision there. On the left-hand side, negative 4 divided by negative 4 is 1, and that's why they cancel out. You have a 1y, negative 4 divided by negative 4 is 1, and 1 times y is y, so you don't need to write the 1. Right here, we have negative 4 divided by, negative 2 divided by negative 4. You can do a couple of things here. Come over here to my scratch work. Negative 2 divided by negative 4. Well, first off, a negative divided by a negative is going to give you a positive. Okay, so you want to know those rules. And then 2/4 simplifies to 1/2. So the most straightforward simplification there is to say that that is 1/2 x. You could also take your calculator and do it out, and it would give you 0.5. And it would not be wrong to put the 0.5 there. It just, again, depends on what else you're trying to do in the problem. So follow directions and ask me if you're not sure. Ask me if the way you're writing it is acceptable. Last step here, positive 12 divided by negative 4 is negative 3. And you can either write plus negative 3, so you can preserve the plus sign and keep this as a negative 3, or you can convert over to subtraction, because remember, there's no such thing as subtraction. It's always adding a negative. So you can write 1/2 x minus 3 or 1/2 x plus negative 3. Either is fine. This would be the form you would want it in if you were going to go ahead and graph it, because if you remember from Algebra 1, this is your y-intercept and this is your slope, which is your rise over run. If you weren't going to do anything with it, you could leave it as 12 minus 2x all over -4. That would also be correct. That's what we call an equivalent answer. It's just in a different form. I'm a big advocate of not doing extra work. So if all the directions say is solve for y, this is the easiest way to do it. If the directions were graph the line, then it's better to have it in that form if you're going to graph it. But I will leave that up to you. I'm going to put another problem up on the screen, and then we will break out and get some practice and some feedback. Okay, so on the one on the left, I want you to solve for y. I didn't write what to solve for, so I want you to solve for y. Again, that's the most common thing that you would want to do with this. So solve for y. If that's easy for you, then I want you to try this one as like just a little bit of an extra challenge, stepping into some stuff that we haven't covered yet. 5t squared equals 30, and I want you to solve for t, not t squared. Solve for t. Okay, for those of you that are working at home or rewatching the video and hoping for another explanation, here we go. We want to solve for y, so I want to get the y by itself. I have 4 times y, and then I am adding in a positive 3x. So first thing I'm going to do is try to get rid of that 3x. It's a positive 3x, so I will be able to do that by subtracting 3x from both sides. Bring down the 4y. And then over here, I have 8 minus 3x. And again, what you're going to do with it from this point on really depends on what the directions say. So if it's just solve for y, I'm not going to touch it. 8 minus 3x, they're not like terms. This is multiplication between the 4 and the y. And I know I can undo multiplication with division. If I divide everything on the left, I have to divide everything on the right. And I have satisfied the directions at that point. 8 minus 3x, make sure that fraction bar goes all the way across, all divided by 4. The way you would say it out loud, 8 minus 3x all over 4, or all divided by 4. If the directions asked me to graph it, this is what I would do. I would take this and I would split it. Oh, a minute. And split it, I would say 8 divided by 4 is 2, and then 3x over 4, I can write as 3/4 x, and then I would switch the order so that I had it in my slope-intercept form. So I would have -3/4 as my slope, that's down 4, right, or down 3, right 4, and then my y-intercept would be 2. Again, this is correct. This is better if you're going to graph it. So just read the directions. If you did the challenge problem, here's how this would look. I want to get t by itself. The 5 is multiplying the t squared. So you always want to notice what is being done. I will ask you guys that question a lot. What is being done? And you would say it's multiplying. The 5 is multiplying the t squared. How do you undo multiplication? Division. So you need to know what's happening. 5 divided by 5 is 1, and that is the reason it cancels out. 30 divided by 5 is 6. But the direction said solve for t, not solve for t squared. And we haven't covered this. That's because this is not a linear equation. This is a quadratic equation. So it requires us to access some other information. How do I undo squaring? Remember from last lesson, solving an equation is all about undoing what you did. So if the answer to what is being done is I'm squaring, then you would ask yourself, well, how do I undo squaring? I undo squaring with a square root. And so I am going to take the square root of t squared. If I take the square root of the left, I have to take the square root of the right. And this gets a little dicey. We want to be careful here. But for the purposes of this lesson, because I don't want to get into whether t is positive or t is negative, we will just say for simplicity's sake that the square root of t squared is t, and then you would just keep the square root over the x. technically, just so I'm covering all the bases, this would be plus or minus. And the reason for that is because like 4 squared is like 16, and like -4 squared would also be 16, because -4 times -4 would give you a positive. And so you could have both the positive and the negative, but I don't really want to go into a big explanation of that now. We'll have time for that later. Okay, so that's a wrap on linear equations part 2.